All right, computer science, unit 6 from Barron's 2D arrays. So we're starting later in unit 6. 1D arrays we covered first semester, and you should go back and review and make sure you understand those problems. We'll do the 2D array problems. Which of the following initializes? That means puts the values in it of an 8x10 matrix with integer values that are perfect squares. Perfect square is 0, 1, 4, 9, 16, 25, so forth. Those are perfect squares, right? And they did point out to you 0 as a perfect square. So first one just creates a two-dimensional matrix with 8 rows and 10 columns, and then doesn't do anything else. You're like, well, okay. Let's see. Now, okay. The next one initializes it and then does a row major, go through the rows for loop, columns through the for loop, does the correct lengths, and then fills each spot in with whatever the R value is times itself. So that should give you perfect squares in each of the spots. And the next one creates the array and does a column major approach to going through the matrix. But let's see. There's one tiny mistake right here. Like here, they use the R value and then they take the length of the rth column, which we usually just put as 0 here because like all the columns are usually the same length, right? So, but that works because the R has been created. And here they do the same thing, but the R hasn't been created yet. So this is the one mistake on this one. So even though it looks good, it's out on a technicality, a very, very tiny thing. And, by the way, we always do rows first, columns second. Now, the first one they're going to say is okay because even if you don't put values into an integer, it will be set to 0 by default by Java. It'll just be set to 0. And even though it says, in our mind, we're thinking it's going to be full of perfect squares like this or something, I don't know. There's lots of different ways you do it. Like this one, it's saying every spot in the first row is filled with zeros. And then every spot in the second row, row 1, is filled with ones. So that's the way this one looks. Okay. And this one was going to do something like that, but it's going to do column by column. So it was going to do zeros in all the first column, ones all in the second column, fours all in the next column. That's what it was going to do. This one just has a bunch of zeros in it. And zeros are perfect squares, so technically that's okay. So 1 and 2. Anyways, that was a little, I think, confusing. Surprised there's only 3 questions out of the, I don't know how many people ask questions. We got a little better response this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people filled out my form out of 21 in our class. So better than half. We were getting less than half before. Let's see. 29 says, consider a class that has a private instance variable. So this is the private instance variable. That's a 2D array called MAT. A lot of times you use MAT for like matrix because matrix is a 2D array. Can be thought of that way. The class has the following method: alter, public void alter, and it gives you take an integer as an argument, and then it goes through. Let's see if we can figure out what's happening before we even start looking at this. We might get a rough idea. It's going through all the rows, and it's going through the columns, but it's starting at the column right after. So it's starting at column right after column C. And then it goes to the end. And then what it's doing is it's saying the current row, and then instead of this would be the column before where we're at. Okay. So this is like backwards. One spot is going to get the current row and the current column. So I think what it's doing is it's moving all the values from the column right after C, and it's moving them all over into C, and then it's going to keep doing that. It's going to move them all over. Now, but the last column I think is going to remain unchanged, right? Because it's always doing. And so when we get to the last column in the array, it's always looking at the previous one and putting that in there. So the last column is going to show up twice. That's my prediction. So you could always kind of run your own little simulation with this example and see what happens. But it says if I think I understand it pretty well now. The 3x4 matrix mat is this. If then alter 1, so this is column 0, 1, 2, 3. We'll change mat 2. It's going to scoot all these over 1, right? And we're going to lose the first column, and we're going to get the last column twice because it's going to get copied into the second to last column, but it's still going to be there. So I think we're looking for 3, 4, 5. Okay. Clearly I'm wrong. All right. So let's see. Oh, wait. It starts at the column after C. So it's going to start here, but then it goes back to that. So, okay. So I think now the first column remains untouched, and these ones get scooted over. So we're going to have 1, 2, 3, and then we're going to have 5, 6, 7, and 7, 8, 9. So column 1 will get copied over, and then the last one will stay the same. So I think we're looking for 1, 2, 3, 5, 6, 7, 7, 8, 9. So I think that is, and that's the right answer. So I messed up, but my misunderstanding luckily wasn't one of the choices. But what you could do is you could go through this code and with this example and start seeing what happens, But it's good to kind of read through the code and just try and figure out what is kind of going on before you even start on it. Okay. Problem 30. Consider the following method that will alter a matrix. Okay, sounds kind of like the last one. It's going to do something to a matrix. It's going to change it. And it says, it's an initialized matrix. Excuse me. Row is the row number. Okay. Oh, okay. That's the argument. So row isn't something that's being created in a for loop. It's given to you. These are the arguments. This is what you're being given, and then you're going to do stuff with it. Now, it creates a variable called num_columns that is set equal to the number of columns. So instead of putting mat0.length inside the for loop, they're getting the value and put it into a variable and then putting the variable in here. But that's kind of normal. So what's it going to do? It's going to start at the row or it's going to look at just that row. It's going to go through all the columns of a single row and replace them with the row value, whatever row number we're at. So that's what it's going to do. It's going to leave the rest of it the same. So here, this is it originally, method call. So we're looking at row 2. So this is row 0, 1, and 2. And so it's going to do this row, and it's going to replace them all with 2s. So you're going to get 2, 2, 2, 2. That's my prediction. So we're looking for 149, 2786, 2222. So that's answer A. And that is it. So best thing to do is to start looking at this code and trying to figure out what is that code doing. And then it'll make it a lot easier to answer the question. Otherwise, you could just try and like use this example and go through the code over and over and over again. That'll take a while to get the answer, but I guess that's an option. Assume that a square matrix, so a square matrix, it has the same number of rows and columns, and it says that we created a new one of size. They use capital letters for final static variables, so those are variables that we're not intending to change. And it says that it's going to be equal to or bigger than 2. So it's a 2 by 2 matrix at its smallest. It could be bigger. What does the following code segment do? So it goes through the rows, but stops at, let's say the size is 5. It stops at the last, it doesn't get to the last row, right? Stops before last row. Okay. And the next one goes to the column started at 0 and it stops. Oh, this is kind of weird. Let's see. This is kind of interesting. What does this do? The size, which is the same number of columns, minus I minus 1. So this is changing every row we go through. This changes. So on row 0, it stops when row equals 0 or I equals 0. It stops before the last column, right? When row equals 1, it stops at before the second to last column. So do you see what's happening? Every row we go, it's going to stop one column earlier. The first one, it stops before the last column, so it doesn't touch the last column. Then what does it do? It does a swap. Okay, now we've looked at a lot of swap methods, especially when we're doing sorting. And even earlier in the class, the swap method takes 2 values in 2 spots and swaps them. And usually what it does is it copies this one into a temporary variable and puts this one here and then puts the temporary variable back here. Otherwise, you're going to lose one in the process. That's a typical swap method. So what is it doing? It's swapping. Let's see. You may assume the existence of swap method. Let's look at the swap method now. The swap method takes a 2D array. It takes an int A, B, C, and D. And you may assume the existence of swap method. Okay, they're telling you what it does. It swaps what's in AB with CD. So when we're in row I, column J, the spot that's there, it's gonna put, like, say when row equals 0, and J equals 0, row equals 0, J equals 0, it's going to put size, which would be the last row and column. So it kind of feels like we could use this example right here. This one's small enough. And if you are going to try and use an example, just try and use a small one. So here, I think what it's doing is it's saying that this spot is going to get this spot, and they're going to get swapped on the first term. And then I think that would be it. Now, a bigger one, I don't know. So do we see the one that's like that? So this would become the other values would stay the same. So this looks like the right one. So it gets reflected through its minor diagonal. Now, by the way, there's a major diagonal and a minor diagonal. So if you have a bunch of values, diagonals are like this and like this. This is called the major diagonal, and this is called the minor diagonal. And if it's going to be reflected through its minor diagonal, that means this is your line of reflection, and things get swapped across that way, which is clearly what's happening right here, right? So that wording kind of makes sense also. Okay. That was interesting. It was kind of a little hard to think about. Okay, 32 says, consider the class matrix stuff that has a private instance variable, private 2D array, mat. So it's just been declared. It hasn't been created, doesn't have a size yet or anything. Refer to the method alter below that occurs in the matrix stuff class. The lines are numbered for reference. So they're just putting these, they might ask you questions about specific lines in the code. And so this will make it easier for you to reference them. Should we read through this and see if we can make any sense of it first? Matrix is initialized integers. C is the column to be removed. So it sounds like we're going to remove a column. Column C, post condition is what happens afterwards. That column C has been removed. And the last column is filled with zeros. Okay, so let's see how they try and do that. So we're going to remove a column, and then maybe they're all going to get shifted over, and then the last column is going to have zeros. So this kind of looks like one of the last couple problems we were doing. So it says poke void alter, we give it a column, we go through all the rows, but then J, which is your column, starts at the column that you want to remove. Okay? Because if you're going to remove a column and shift all the later ones down, then you can skip the first ones before it, right? So that's what's happening. And we're going to go to the end, and it's going to say the current spot is going to get filled with the one to the right of it. So that means the value to the right is going to replace this value. And the column to be removed gets lost in the process. And this will keep happening. Now, we should also be considering potential problems that you should be looking for in your old code. Anytime you go J plus 1 or J minus 1 or I or whatever, be careful that you don't go out of bounds. And when we get to I is less than mat length, which would be the very last column, and we try and access the column to the right of it, which doesn't exist, we're going to get an index out of bounds. So that's probably something they're going to ask us to either fix or identify. The intent of the method alter is to remove column C. So they say if you do column, this is column 0, 1, 2, 3. So if we're going to remove column 1, means it's going to go away. These are going to get shifted over. And then we're going to have a bunch of zeros. They didn't show us the code to insert zeros in the rightmost column. So I guess we don't have to worry about that. So that's what should happen. And it says the method does not work as intended. Like I said, I think I spotted an issue. Which of the following changes will correct the problem? So you got to fix it. So to make sure we don't go past, remember we're going to replace the last column with zeros anyway. So we can skip the last column when we're moving all the columns over. We should, because that's the one that's going to get filled with zeros, and then we won't get the index out of bounds. So what we should do is probably stop J at mat length minus 1. Mat length minus 1. So that looks good. And I don't think you need to make any other changes. That's on line 10, which is the one we're talking about. 10, 11, they're saying, now there could be multiple ways to solve this. That's the most obvious one in my head, but there could be other creative ways of solving this. So it says, change lines 10, 11 to, so instead start at the column after the column to be removed. Right? That's what that means. That's what that's doing. And then instead of saying the current one equals the next one, let's say the previous one will equal the current one. And then we'll stop at length. I think that'll work. I think because when we get to the last spot, we're copying the last one into the previous one, and then we never try and copy anything, and The only thing to watch out for here, though, is that like, what if we want to replace column 0? I think this would still work. So even if c equals 0, it would start at column 1 and put column 1 into column 0. So I think that would work. So you also want to check index out of bounds on both ends, not just on the far end, but even at the earlier, on the beginning side. So I think that one's good. 10, 11. This one, what are they doing? They're saying start at the end, start at the last column. And some of you guys have done this before in your code. Kind of go through, traverse the matrix backwards, start at the end, and then decrement. So start the last column and go backwards. As long as J is bigger than C, this is the column to be removed. So we're not going to actually get to the column to be removed with our J value. But this kind of does something similar to the last one. It says we'll take the previous value, put the current one into the previous one, and then on and on. And that would also work. So I think all three of them. Oh, shoot. Now I'm checking my answer. So I'm doing this from scratch, and E is not right. There's something wrong. Goes backwards, but next column to the left copies the previous column. Okay, so what's wrong with the third one? There's something. Goes backwards, and it copies. I don't know. Let's see. So I missed something. These Roman numeral problems are fun because there's 3 separate problems that you have to evaluate, and then they got to all be correct. So I'm just trying to figure out. Goes backwards, but the next column to the left copies the previous copied column to the right. Oh, you know what's going to happen? This is sneaky. So since we're going backwards, I could use an example right here. Let's use this one: 210 657 843 932, and this is something we could always do. So it starts at the end, and it says, let's put all these guys in here, right? So the result is, after that first step, that we have 932, and then we still have 932. Now those are going to get replaced with zeros later on. And the next step says, all right, we'll copy these guys into this. Okay, so then we get 932. 932 is still there. 932. What it does is because we're going backwards, it keeps copying the last column that we already copied into. And so the very last column gets copied throughout the array until the column to remove. So that's not going to work. But that was tricky. Got me. I didn't see it. But I mean, these tests, AP tests, are hard, and to get like a 5 on computer science, I think you need like an 80% or something. So I mean, you can miss 1 out of 5 problems and still get an A. All right, let's try this one. Number 33. The question refers to the following method: public static Boolean returns Boolean. It's public. Static means it's in a class that we're not making actual objects out of. It's called is there. It takes, these are the arguments, right? It takes a 2D array, takes a row, and takes a column, and takes a symbol or a string, which is probably like a letter or symbol or something, some kind of character. So Boolean, there's a new variable called Boolean yes. It's called yes. It's true false. Int I and count. These are some other local variables in the method that are just created. And it starts at I equals 0. So this is weird because it seems like we could just put int I right here and put int I right here, and we wouldn't need to do that, but whatever, it does the same thing. Count equals 0. So a count might be we're keeping track of something. How many things are like this, or so it goes through the whole 2D, it goes up to size, which I'm assuming is the size of the 2D array. And later down here, you see that it is the size. So it's kind of like the number of columns, number of rows. It goes through all the rows. So it's just going through the rows. Well, I don't know. Yeah, it's going through all the rows of a specific column which was given to you, right? It's going through all the rows of a certain column. And it's checking dot equals is for comparing two objects, equality, and in the string class there's one. These are holding strings, 2D array of strings. If it equals whatever symbol that they asked you for, then the count goes up. So it's like we're counting how many of these symbols are in all the rows of that column, just that column. It says yes equals count equal size. So this is an interesting thing. This is like an if statement. This is going to give you true or false because these are two Boolean things. So, or not even Boolean. Double equals is comparing whether these are true or false. So if count equals size, that means all the what are we going to call them? The whole row has whatever symbol was. Okay, so the whole row got filled up, and then yes will get turned to true. Now by default, this is set to false, even though it doesn't show it. But if you don't do it, when you create a Boolean, Java will by default initialize its value to false, and for integers 0, and for doubles 0, and for objects null. So then count gets reset back to 0. Okay. And then we go through, we do the same thing, going through all these I values. And it says if mat row I equals symbol count plus plus. So this looks just like the previous thing, right? But, okay. But now we're looking at a specific row and we're looking at all the columns. So here, I messed up here. The whole column has the symbol. This one is looking for if the whole row has the symbol. So it's like we're looking for, we have a 2D array and they say, well, look in this row and look in this column and do they all have the same symbol that we're looking for? And if they do, well, it says if yes, which was from before, if this is true, this is an OR, right? If all the symbols in the column have the symbol, if all the spots in the column have the symbol, or if all the spots in the row, or if both, it should return true. Okay, so I think that's worth it going through there, trying to figure that out. And then if you understand it and answering the question would probably be quick. Which of the following conditions on a matrix mat of type declared in the code segment will by itself guarantee that is there mat22 has $, will have the value true when evaluated. So they're trying to ask you to make sure that it returns true. Which of these will for sure return true? And remember, this is row, and this is column, and this is symbol. And so element will have true. The element in row 2, column 2 has $. No, that's not good enough. It needs to be all of them in a row, all of them in a column. Okay. Which of the following conditions will by itself guarantee that this will return to? So we're trying to guarantee this returns true. Now, while this is a true statement that if this is true, then this will be true. That either, that spot where they intersect, if one of them has all the symbols, then that spot's going to have it for sure. But that's not enough to guarantee that all elements of both diagonals. No, diagonals would be like this. I don't think that's going to work. And let's see, all elements of column 2 are dollar signs. So yeah, this would do it if, so I'd say 3 only. So, but the only way I figured that out was by thoroughly understanding the code before that. Let's see. 34. The method change negs below should replace every occurrence with of a negative with a 0. So it's going to replace all the negatives with zeros. Okay, make sure you understand the goal. And it has a precondition that's initialized with integers. Postcondition, all the negative values replaced with 0. Okay, plug stack void change negs, which is correct replacement for code. So we have to figure out which of these will do the job, and it's very possible that multiple, all of them could do it in different ways. So, and they'll all kind of probably seem like they'll work, but there'll be something maybe sometimes very small that doesn't work. Okay. So, which is the correct replacement for code? So this goes through all the rows and all the columns. I think this should be a simple algorithm. We're looking for negatives and replacement 0. Go through all the rows. You got to go through all the rows and all the columns. And if the current spot is less than 0, then set 0. That seems good, unless there's something weird about it. The next one does column major form, columns, rows. That looks good. It's just going through columns first instead of rows. This is a for each loop. You guys remember how for each loops work with 2D arrays? We want to first copy all the rows. So this is the 2D matrix, and we're getting 1D arrays out of here, and we're going to copy them into this variable that we've called, this is just a variable that we've called row, which is kind of a nice variable if you're copying rows. Then after that, it goes through the row, which is a 1D array, and it goes through each element, which are integers, just regular integers, and it copies them into something called elements. So that's actually giving you the actual spots in there. And if element's less than 0, then it sets element equal to 0. Now, while this seems good, logically, it seems like it's going through the whole thing and checking them all. And the problem with for each loops is you can't use them to create objects or replace things in your 2D array. You could manipulate objects using their getters and setters if it was an object, but you can't. This is just a copy of what's there. This isn't the actual spot in the 2D array anymore. This is a copy of what was there. So you're looking at the copy, which is good enough, but then to set the copy equal to 0, it's not going to give you an error. It's just not going to do anything to the original array. So it's just not going to work. So you have to understand how for each loops work. They have limitations sometimes. I mean, they're nice compact ways of doing, for loops, but they do them differently. And sometimes you can't do what you could do with a regular for each loop. So correct, we're looking for the correct ones. Sometimes we're looking for the ones that are incorrect. So we want 1 and 2. So that was mostly a test of your knowledge of how for each loops work, I guess, because all of them logically seem good as far as the strategy. Now 35. I don't know. One person had a question on it, so I guess I'll do it. Two-dimensional array of doubles. It's called rainfall. Will be used to represent daily rainfall for a given year. In this scheme, rainfall month day. So this is going to be your rows and your columns, I guess, right? It's always row first, column second. So the rows are going to be months probably, or the month. And the columns can be the day, represents the amount of rain on a given day and month. For example, this would be January 15th. This would be December 25th. The array can be declared as follows. So it's giving you 13 months. Kind of interesting. 13 months and 32 days. But maybe we're going to ignore the first. This creates the 13 rows index 0 to 12 and 32 columns 0 to 31, all initialized to 0.0. Row 0 and column 0 will be ignored. Column 31 and row 4 will be ignored since April 31st is not a valid day. In years that are not leap years, columns 29, 30, and 31 in row 2 will be ignored so it's kind of saying, hey, there's certain days that won't get used because certain months have less days. Precondition. Rainfall is initialized with values representing amounts of rain on all valid days. Invalid days are initialized 0.0. So there will be values in those dates, but they have 0.0 on them. February 29th is not a valid day. Postcondition returns average rainfall for the year. Public double average rainfall takes the double rainfall to the array, creates what we call an accumulator, something to add everything up. Which of the following is correct replacement for more code so the post condition for the method is satisfied? So which of these gives you the actual average? So this goes through month 1, skips month 0, which is okay. They told us that. And goes through all the months and all the days and adds the rainfall for each day to the total. And then when we're done, divides the total by 13 times 32, which would be like all the days in a year, which I don't think is true. We shouldn't do that. 1, you're supposed to ignore the first column anyways in first row. 2, there's these extra days in these months that are just going to have zeros in them, which are fine. We can add those in. They won't mess our total up. So we don't have to worry about those days when we're adding it all up. But that doesn't give you the number of days in a year. It needs to be 365. So in the very next problems, you see that, and that's why this one is bad, because it's going to divide by too many days. It's going to divide by all the extra days that aren't actual days that have zeros in them that we added into the total because it was easy and it didn't mess it up. This one, everything's the same except for the 365. So that one works. Next one is a 2D array. Now we just saw a problem with 2D arrays in the last problem. But are we trying to change the values in the 2D array in the for each loop? No. So if you're not trying to change values, then you shouldn't have to worry about anything. We're just pulling the values out, adding them to total, and that should work also. So both of those should work, 2 and 3. Okay. Next one is 36. The question is based on the point class below. And I feel like we had something like this in unit 5, like a point class. It's a point. It has an X coordinate and a Y coordinate. They're set to private. They're private instance variables. There's a constructor, right? This is a 2R constructor. And then returns the X coordinate. There's a getter for the X. There's a getter for the Y. There's a set, and you change the X and the Y with the new X and Y. So this is kind of basic class, getter setters, private instance variables, constructor. The method change negs below takes a matrix of point objects as parameter, replaces every point that has at least one negative coordinate with 0.00. So this is kind of like the negative 1D or the negative matrix getting replaced with zeros. The method change negs. Okay, let's see. Precondition, point objects, postcondition, all of them that have at least one negative coordinate get replaced with 0. Both coordinates get replaced with 0. So which is the correct replacement for the code to do this job? Okay, so we definitely want to go through all the rows and columns. So go through all the rows and columns. If you got to use the getters and setters. So if the X coordinate of that point is negative, or the y coordinate at that point is negative, then we use the method set point to 0, 0. So that looks good, unless I'm missing something very minor. This one does column major form. Everything else looks the same, and that should work. We're just traversing the 2D array in a different way. And then we have a 2D, then we have a for each loop. And again, you got to be careful for each loops if you're trying to actually make changes to 2D array. So it goes through, it pulls, this is our 2D array, it pulls each 1D array out and puts it in a row, and then we look at each 1D array and we pull each point out, and we call it P. And it says if this is kind of doing the same thing. It's going through all the rows and the columns, and then it's getting the values out of each column. And this looks good. And then it says, now you might be wary of this because we just said we couldn't change the values on a couple problems ago. But if it's an object and it has a mutator, then you can use the mutator to make the changes, and that works. Now, the things you can't do with objects in a for each loop is you can't set it to null. You can't set a spot to null. You can't replace it with a new object, when you create a new object, but you can use mutators on the object that's there to make changes to it through its setter method. So they should all work. Let's see. 37. A sample tic-tac-toe board is a 3x3 array filled with either X's, zeros, or blanks. Here is a class for a game of tic-tac-toe. Tic-tac-toe. You have a 2D array of strings. You have final, static, final. So these are constants. There's always 3 rows, 3 columns. This is the constructor. It initializes. So we declared it. This creates it and initializes the board, and goes through the rows and the columns and puts empty spots in them. So this is like an empty character. They need to be strings instead of putting null. And that might be good for like printing stuff out. If you put nulls in it and print out, it'd look weird. Okay, so you have row, column, symbol to be placed. So one person put X's, one person put zeros. So that's the symbol. Square board is empty at first, and then post condition, the symbol is placed in that square. So this is just one turn. Okay, this represents one turn. Make move. You tell it what the row, column, and symbol you want to put. So, and then that spot gets replaced with that symbol. Then it creates a string representation of the board. So this is like a 2-string, right? Oh yeah, there you go, 2-string. 2-string, and so that we can print it out and see what the status is so far. Okay, and then it would give you something like that. So 2-string, it sets string equal to S, which is like nothing, not even empty space, but it's just like instead of null, it's just nothing. And then it returns it when you're done. So we got to build this up. So we're probably going to have to keep adding stuff to the string, probably use kind of like a for loop to go through the whole thing and put what's there in there. And so we'll go through row by row. We'll need a new line at the end of each row, right? And it has these little spots here, kind of boundaries that will be at the beginning and end of each row. And then we'll print out everything that's inside of it. We're not actually doing the printing out. We're creating the string that you then could print out. So we're looking for the correct one. This goes through the rows and columns, and it let's see, S equals S, what we have so far, plus a line. So at first, there's nothing in S, so it creates a line, and then it puts the current spot there, so whatever is there, like an X, and then right after that puts another line and has a new line. I don't think this is good because I think this is just gonna put, let's say that this is our board. Okay, just an example. It's going to put this, and then it's going to put the lines around it. Then it's going to do a new line. It's going to put this, and then it's going to do a new line. It's going to put this, and then it's going to do another new line. It's going to put this, and it's just going to print one long column. So I think the new line needs to be somewhere else. The new line needs to be after we finish a row. So that would be you go through all the columns in a row, right? And then you should do the new line after this. So I think you would do S equals S plus slash. And then I think what we want to do is do this. So this needs to happen here. This needs to happen before going through the whole row. You need to do the S equals S plus. Okay, so these need to get moved out, and then it'll just do it once and then we won't do the new line until we've finished it. And so this would give us this, and then it'd do X 0 0, and then it would do this, and then it would do the new line. So I think that's what we want to do. So I'm looking at what's wrong with this and thinking of how it should be right, and I'm probably look for that in these other ones. Now there's only one correct one here. It's not a Roman numeral thing. So here, this one does that right, but this needs to be after the for loop. So that one's gone. This one does that right. But this one is doing this after we've done everything. This needs to be inside the for loop for rows, but after the for loop for columns. So I think that one's out. This one does that right. Now, don't get messed up with this indentation. This is bad. This is going through all the rows and just putting a bunch of lines, and then it's going through all the columns afterwards. This just looks weird. I just don't think that one's right. Now the last one, you could just try and find the one that looks like what we predicted should happen. This is good. It happens before. This is good. It happens after. Even though there aren't these marks, if you don't have the curly braces on a for loop or an if loop or a while loop, then it only reads the next line as being inside of it. So this is it. D is doing something weird. There needs to be curly braces for sure, and it left those out, so it only reads this as the next thing in there, and then this needs to be afterwards. The result of what that does, I don't know. So there you go. And that's it. Is that the last question? That's the last question. So anyways, I hope that helped, and there we go.